2, 3, 4 years ago, I was skeptical about the effects of climate change. I mean, how could this be a serious issue, yet governments were not taking stern action about it? This was until 2020 happened, when we were all forced to slow down. I had time on my hands. I chose to look at the depth. Indeed, this is a serious problem. Droughts are becoming longer, storms more severe, floods more erratic. Even in my home country, Kenya, we've had 3 of the longest and the most severe droughts in our history over the last decade, with the worst of them all going on since 2020. How then can we take meaningful action to address these issues? My name is Mitchell Odhiambo, chapter lead of DINA Kenya, and in collaboration with our project partner, Measuring Carbon, we designed this project to focus on CO2 emissions, one of the biggest contributors towards climate change. Measuring Carbon is a company based in the US that helps organizations measure and reduce their carbon footprint, enabling them to meet their sustainability goals. After all, what cannot be measured cannot be improved. Using NASA's or CO2 and CO3 satellite data, these are satellites whose primary mission is to measure atmospheric CO2 concentrations from space. We designed this project with the following 4 objectives in mind to be accomplished across 8 weeks. First, to teach people how to access publicly available data on CO2 and critical CO2 emitting sector. Secondly, visualize CO2 trends in Kenya over time, provide insights on the emissions over time. Thirdly, to develop a machine learning model that could be used to track progress across cities. And finally, to create a dashboard for this machine learning model. Here's how we were able to do that over 8 weeks. We took the first 2 weeks to go through NASA's remote sensing tutorial so we can better understand how CO2 measurements are taken from space and how these CO2 measurements could be used in support of local and regional climate study. We then took another 2 weeks for thorough literature review, going through research papers and material by other scientists to get insight on the practical approaches they were using to help address this issue. And with a lot of support from Measuring Carbon, we got insights that informed our climate modeling approach and also the data points we needed. We took the following 4 weeks for exploratory data analysis, modeling, and visualization. And here's what we learned. From a technical standpoint, my team learned how to access satellite data from NASA's website and convert it into a usable form for data manipulation. Secondly, we also learned the value of exploratory data analysis. All these different data points from industrial emissions, wildfires, demographic factors, and so on and so forth. How to do your feature engineering and put your data together so you have high quality data to build a machine learning model. From a project management standpoint, I also learned the importance of being efficient in workstream management. We took the whole workstream and broke it into 4 different subtasks: research, modeling, data analysis, and deployment, just to allow me to leverage the expertise on my team. So you have people playing to their strengths and also providing opportunity for the AI engineers I had to develop and improve in their areas of growth. Now we have a machine learning model that we can use to track progress across cities. This is a tool that we can actually use to support decarbonization efforts and contribute towards policy conversations in our country. If this resonates with you or you take interest in this project, you can find more about this either by reaching out to us or on our GitHub account, the link of which will be provided below. Up there, you'll find the interactive web application we built, the machine learning models we have, the code base and visualizations that we built, similar to what you can see on screen. Thank you.